Welcome to the Insightful Professor. With this video, we'll examine how we can handle exceptions in PLSQL code. What we'll do is begin by examining the concept of an exception, explaining what it is, and then explaining how we can capture these or intercept these during the execution of a program. What we want to emphasize from the start is that an exception is a runtime issue. This is not something detected during the compilation of your code, but is detected by the system when your code is executed. We'll provide examples of exceptions and show how code can be written to deal with these and keep the program up and running or allow it to terminate gracefully rather than incurring the default error message. Let's begin by explaining what an exception is. In PLSQL, an exception is either a warning or an error encountered during execution. Oracle Database predefines thousands of exceptions, and information about these exceptions can be found in the database documentation for the messages and codes. But let's be a little bit more precise. In addition to the internally defined exceptions, we can create our own. So let's talk about the difference between these. An internally defined exception is said to be raised or detected automatically by the runtime system. Such an exception might be related to something like attempting to divide by 0 or trying to store a large character string in a variable that can only accommodate a short character string, kind of a size error or value error. On the other hand, user-defined exceptions have to be explicitly defined by us within our code and must also be explicitly raised with a special statement called the raise statement. These exceptions are generally used to deal with the violation of a business rule, and such errors could be the result of, say, overdrawing an account, resulting in a negative balance, or detecting some kind of an expired date. The internal framework for dealing with exceptions is the same for both the internal or predefined exceptions and the user-defined exceptions. This means that we do not have to write different code for dealing with different types of exceptions. We simply specify the type or name of an exception and how we wish to deal with the event should it arise. So regardless of how an exception occurs, it's handled through the same framework. When an exception occurs within an application, we must specify the name of the exception in the exception handler. So some internal exceptions have predefined names, such as zero divide or value error. Note that most internal exceptions have not been assigned names. So internal exceptions that have not been assigned names by Oracle can be given a name within the PLSQL program for the purpose of being able to focus specifically on that exception within the exception handler. Note that if we create our own exceptions, user-defined exceptions, these must be given names. So when we define an exception, we actually give it a name as part of that definition. Recall that PLSQL is a block-structured language. There are potentially 3 distinct areas or subblocks within a PLSQL program. There's a declaration section, there's an executable section, and there's an exception handling section. If our application includes a user-defined exception, this would be declared in the declaration section of the program. We don't have to declare these internal exceptions. Oracle Database is already aware of these. If a business rule violation is detected, the execution section of the application will have to signal a violation of the rule by raising or throwing the exception by executing a raise statement to announce that this user-defined exception has occurred. Again, if there is an internal or system-defined exception that occurs, it will be detected automatically as the result of some instruction executed within the executable section, and we need to do nothing else ourselves to trigger this event. Finally, when the exception is raised, the current PLSQL block is halted and control is passed to an exception handler, which is defined within the exception block. When the exception handler completes, the current block ends and control returns to the enclosing block if one has been defined, or to the host environment if no enclosing block has been defined. If an exception is not handled in the PLSQL program, that is, if we have an unhandled exception, an error number and message will be sent to the user of the application. But note that control is not returned to the original block. A developer must be aware of PLSQL's event-driven model to properly design an application that includes error handling routines. PLSQL intercepts and processes errors using what is referred to as an event-driven model, as opposed to a linear code model. When an error occurs, an exception is raised and control is automatically passed to an exception handling section of the code. Let's go back for a moment at this diagram. The execution of a statement that causes an exception to be raised is within the begin section, the executable section of the block. No matter how many instructions have yet to be executed that follow the offending instruction, control will be immediately transferred into the exception block, and it's as though you bought a one-way ticket. You're not coming back. Control is thrown into the exception block, and the system looks for an exception handler to deal with the event that has just occurred. What happens after that depends on the overall structure of the program. Note that with this approach, by using PLSQL's exception handling mechanism, the application logic is effectively contained within the executable section, and the error processing logic is separated from that application logic, placing it in the exception handling routine. Here's a list of the predefined exceptions. We have two columns here. Looks like quite a few, but if you look at the Oracle Error Messages manual, you'll see that there are many additional things that can go wrong, problems that could occur during execution of your code for which there is no associated exception name. This is where we make the distinction between the predefined exception and something that would be considered an internal exception but does not have a name. It's not been associated with a name. That's effectively what Oracle means by predefined, is it's an internal exception that has been given a name and you're ready to handle it using that name. So the runtime system raises predefined exceptions implicitly or automatically. We need to do nothing to cause these exceptions to be detected by the system. This is in contrast to the user-defined exceptions, which we must declare and we must throw or raise using a raise statement. That would signal the event has occurred. Finally, we reach the syntax for the exception handler. Coded after the word exception, we would say when and use one of the names of the exceptions. We follow that with the then keyword and have a sequence of statements, which could be one or more statements, that will execute if that particular exception is the problem that has been detected. But again, control will pass from within the executable code wherever the exception is detected, and regardless of how many remaining instructions have yet to be executed. And we will be thrown into the exception block and go through the list of when-then combinations. When indicating here's the situation, then this is the action or response to that particular situation. So observe that the syntax and behavior of exception handlers is similar to that of a case statement. We work from the first one sequentially down to the last one listed. This particular syntax diagram shown here is just showing a single when clause, hence only one exception handler is defined. But we could have multiple when-then combinations handling many different exceptions. The expanded syntax of the exception handler says that we could possibly handle more than one exception with a single exception handler block by listing the exception names connected with OR. So for example, what we could do is say when zero divide or invalid number, then take the same action if either of these occurs. So this presents the issue of distinguishing between the specific events that have occurred. If we're handling two different events in the same way, the same then statement sequence, how do we know specifically which problem occurred? There are two built-in functions, SQL code and SQL error message, that allow us to extract information from the system and determine specifically the cause of the problem. SQL code returns the number associated with the most recently raised exception. In an exception handler, SQL code returns the numeric code of the exception that is currently being handled. Outside of an exception handler, SQL code returns a value of 0. For an internally defined exception, the numeric code is the number associated with the Oracle database error. This will be a negative number, except for the situation where we have no data found, which could be considered an error, could be considered a warning. In this case, no data found returns a positive number, plus 100. But all other events, if you refer to the chart that I presented a moment ago with the list of those predefined exceptions, have negative numbers. So SQL code will return that value. SQL error message, or SQL error M, returns the error message associated with its argument, or the SQL code of the most recently raised exception if you don't pass an argument. So it has a default argument. The value passed to SQL error message should be a negative number in order to receive the appropriate error message. So you can retrieve the error message with SQL error message, and this will return a maximum of 512 bytes. This is the maximum length of an Oracle database error. Now, a complete list of all valid Oracle error numbers can be found in the Oracle database error messages reference. So if you look online at the documentation, you can find all of the possible errors, not just those for the predefined, but for all internal errors. One other comment about these two functions. Neither SQL code nor SQL error message can be used directly within an SQL statement. These must be assessed within a procedural PLSQL statement. Here's an example that brings this together. We have a few variables declared, then we're attempting to select a row from the course table for course number C33. Remember that CNO is the primary key, so this is a singleton select, and we should get one row. We then take the credit that we returned from the database and the fee that we returned and do a division operation. Provided that the fee is not 0, the division will be successful. We'll make a call to DBMS output put line and report the values that we found. However, if the fee for this course is 0, we'll be attempting to divide by 0, and if that is the case, we skip over the DBMS output and we're thrown into the exception block. Within the exception block, the system kicks in and says, what's the problem? Is it 0 divide? If it is, it executes the DBMS output put line and terminates. Nothing else is done. But if the triggering problem was not zero divide, it falls to the next when. And this is how it goes through the list of exceptions sequentially. So if it's not zero divide, was it anything else? That's what others refers to. And of course, that will be true. Let's take a look at this program example, but without the exception handler. What we want to do is see what the response will be from the system in the event that it detects an error and we've not handled that error or exception. What we get is a problem that says error at line 1. Well, that's kind of deceptive because line 1 is the declare statement. If we read on, we see that the problem is the divisor is equal to 0. That's an explanation of the divide by 0 error. But where was it actually detected? It was detected at line 11. Line 11 is where we encounter the division that we were referring to. Turns out that the fee for C33 happens to be 0. We're attempting to divide credit by 0. That's where the exception was actually detected. That's the default behavior. Let's modify this code to go back to the original example and include the exception handler and see how that causes the code to behave a bit differently. Now we've included the exception handlers. We have two of them. We have the zero divide, we have the others. Again, it will go through in that order. Now notice that what we get is a graceful termination of the program. This is the same set of instructions that we had previously, retrieving course C33 and attempting to divide its credit value by its lab fee value. That, of course, causes an exception to be raised, but rather than terminating the program, control goes from line 11, where the error was detected, into the exception block beginning at line 13. It then says, is the problem that we're experiencing zero divide? And it turns out that is true. So what happens is we take the action on line 15 and display the message error, zero fee value. And then the program terminates gracefully. Let's make one more modification to this, just to show you another possibility. What we've done this time is we've added an additional exception handler for value error. We listed that first, then zero divide was listed second. Again, the same problem occurs. We receive a value of 0 for a lab fee and attempt to divide by that 0. But notice when the exception block is entered, it says, is the problem value error? If it was, the message would say error, value error detected. But that's not what we see. So this means that it goes sequentially. Testing on line 14, that was not successful. Goes to line 16, finds, oh, that one is the case. This is true, therefore we respond and execute line 17. So the order in which we list these exception handlers is important in terms of when it's going to be encountered and how the system will respond. Before we return to our presentation, let's consider a couple more examples. Here's one that has two different exception handlers treated the same way. On line 15, we're testing for either the zero divide condition or the invalid number. If either one of them is the offensive condition, then we'll enter this block and execute lines 16 through 19. If it is an exception other than either of these, it's an unhandled exception. Note that within this block, we're receiving the SQL code by invoking the SQL code function. We store that value in a local variable, and then we make a couple calls to DBMS output to present the information that we found about the problem. We're identifying the SQL code, the actual error code, and we're passing that code to the SQL error message function to get the actual text of the error message. When we enter the exception block, If it is either one of the exceptions, we're doing exactly the same thing. So this is why if we're handling multiple exceptions in the same way, we have to be able to extract information to inform the user of the specific problem. So let's give this a try. What we want to point out regarding the output is there is no line number at which an error occurred. This is because the program actually terminated gracefully. We intercepted the error, and then we chose to put out a message very similar to what the system would have put out had we not had an exception handler. The point is that we have much more control when we use an exception handler. We can intercept the error and then provide perhaps a more descriptive or meaningful message to the user rather than having them receive the default message. I just wanted to show you the mechanism that was available here for intercepting the error and extracting the information. Let's consider what would happen if we didn't have the exception handler. If we remove the code for the exception handler and then run it, well, we'll see that we'll get a similar result, except an error actually does occur. So notice previously we had put out the word error and then reported the error information. But this time, without the exception handler, the system simply abruptly terminates the code, tells us what the problem is, and gives us the location of the actual problem. Another factor to consider is scope. Remember that PLSQL is a block-structured language. The applications we've been using for demonstration purposes have been anonymous blocks, introduced by the word declare, but not given a name. Therefore, they could not be invoked multiple times. But we also talked about subprograms. In another video, we discussed the idea of stored procedures and stored functions, where we assign a name to a PLSQL application, and we also define a signature which allows us to communicate with that subprogram, passing information into it through parameters or arguments. But with respect to scope, we're talking about multiple blocks that communicate with one another. So it's possible that we could have a nesting of blocks, which again will contribute to the notion of something being local versus something being global. So scope applies to variables, constants, but also to exceptions and to exception handlers. So it's possible that we could have an exception handler defined in one block, but not in another, and the blocks are communicating with one another. Depending upon which block encounters an exception, we'll have to consider how the system will deal with that. Here's an application that has a PLSQL block within a block. We have the main program introduced by the word declare, and its executable section is introduced by the word begin and runs all the way to the end of the code. But within the executable section, we have another anonymous block introduced by the word begin, and it has a local exception handler. In this program, we attempt to retrieve information about a particular course using a nested inline block. If course C12 exists, then a call to DBMS output will be executed. If course C12 does not exist, the no data found exception handler receives control and no action is taken. However, we've intercepted the exception and the error is not returned to the user. It is as though no error occurred. Note that this is something that should be done only if the error is an allowable condition. For example, if the error was divide by 0 and we intercepted it and did nothing, the user would never know that an error had occurred. So we want to use this technique with great care. Now, after dealing with the error, program execution continues. So if no error was encountered, a call to DBMS output is executed to display the name of the course retrieved. If an error was encountered, the name variable will still have its initial value of null. We test for this value and indicate that the record was not found. Here we present the example we just discussed. Currently in my database, there is no course with a course number C12. Therefore, when we execute the select statement on line 6, an exception no data found will be raised. The exception handler on line 10 will then execute. It will do nothing. We have the null statement. Then the inner block, the inline block, will complete gracefully. So we'll flow through into line 13, specify that we're leaving the block, and then what we'll do is test the value of name. Because name was not explicitly initialized, it's assigned a null value in its declaration on line 2. So on line 14, name is null, evaluates to true, and we should see the message no record. And there we are. Now let's change this code slightly. Let's go and look for course C11, which does exist in my database. Now when we run the code, the select will be successful. No exception is encountered. We'll skip over the exception block and fall into line 13. But the value of the course name will have been inserted into the variable as a result of the successful select statement. Therefore, when we get to line 14, name is null will not evaluate to true. We'll take the else and we'll display the value of the name we retrieved from the database. The result is Intro to CS, which is the name associated with course C11. A user-defined exception can be added to our application. It's coded to handle application-specific exceptions, like account balance has gone negative or some kind of a date has expired. A user-defined exception has two significant differences from a predefined exception. It must be declared in the declaration section of a program. The system knows nothing about it until we make this declaration. It must be explicitly raised by the raise statement. The system has no way of determining when the exception should be thrown, so we must use a raise statement to tell the system, throw the exception or raise the exception. An exception is declared in the same way a variable is declared, but in place of a data type, the keyword exception is used. So we provide an identifier and then exception, and then of course a semicolon to terminate the statement. An exception handler must be coded in the exception section to handle the exception when it is raised. So a user-defined exception must be raised explicitly with the raise statement, which is coded as raise, and then we use this exception name that we've assigned in the declaration section. Here is an example of an application with a user-defined exception. In this program, we attempt to reduce the current lab fee by $10. If the resulting lab fee becomes negative, we raise an error, as this violates a business rule. So we declare a local variable called fee and another local variable called cNumber, into which we'll retrieve values from the database. But the most important part about this program is that we're declaring something called bad fee, which has a data type of exception. This is the user-defined exception. Now, by itself, this is useless. It's meaningless. We actually have to do some kind of a conditional check to see if a business rule has been violated and then raise the exception. So we're using course number C33. We select from the course table the lab fee, and then we just assume that the lab fee is okay and subtract 10 from it. After we've done the subtraction, Then we check the value of the resulting lab fee. If it is now negative, if it's less than 0, then we violated business policy. Therefore, we raise bad fee. We throw the exception. The update statement and the commit statement that follow the if statement will not be executed if we actually raised the exception. However, if the fee had not gone negative, then the update and the commit would be successful, and that would terminate execution of the program. If the fee is negative, we raise the exception, skip over the update and the commit, and enter the exception block. We check, is it a bad fee exception? When bad fee, then we take the action of displaying the message negative lab fee. If it's any other type of an exception that's encountered, we've not handled it here. That's the basic idea of a user-defined exception. So what have we covered in this video? Well, first we explained the concept of an exception in the Oracle database. We reviewed the basic structure of a PLSQL block, showing where the exception would be raised or thrown, and where an exception could be dealt with. In the case of user-defined exceptions, we indicated where that exception would be declared. We presented the syntax for declaring an exception handler in PLSQL, and we provided several examples of doing this within PLSQL code. We introduced two predefined functions that can be used for error handling: SQL code and SQL error message. And we mentioned that there are two categories of exceptions: the internal or system-defined and user-defined. And we provided examples of these predefined system exceptions and an example of a user-defined exception. I hope you found the video useful, and if so, give us a thumbs up. Consider subscribing to the channel. We'll probably put another video out in a little bit dealing with database triggers, another application of PLSQL. So if you subscribe to the channel, you'll be notified when we post that video. Once again, thanks for watching.